Hey, so for programming assignment 3, we're going to simulate a UDP pinger, which means that the client will ping the server and the server will return the same message that the client sent. And we'll store the round trip time, the amount of time it took for the message to go to the server and receive a response. And we'll also simulate packet loss in the server. So the server will generate a random number, and then if it's within a certain threshold, then it will consider the packet to be lost. So yeah, the server is already pre-written. You can download it in this zip file here. So I'll go ahead and do that, and I'll click download. Okay, so that's downloaded to my file explorer. And let me unzip it. Should be in my downloads folder. So extract all. Okay, so I have my file here and I need to simulate it. I need to simulate the UDP client and server pingers in Mininet. So I'll start my Mininet virtual machine. Okay, and then login is Mininet and password is also Mininet. Okay, so now that I have my Mininet virtual machine running, I need to transfer the server file to the virtual machine. So I can determine what inet address this is running on by running if config. And the inet address 192.168.56.102 is what I'm going to use to transfer my pinger server file. So I'll go back to my extracted folder. And if you don't have PuTTY installed, you should do that. I'm going to type PSFTP for PuTTY Secure File Transfer Protocol, which is the tool that I'm going to use to transfer the file from my local machine to the Mininet virtual machine. So the command that I'm going to use, I think it's from the previous homework or programming assignment. So I'll just go to, yeah, so programming assignment 2, how to copy a file from your PC to Mininet. And I'm going to be using this here. So let me connect to the Mininet virtual machine. So open Mininet at, and then I'll type in the inet address. So let me move this to the side. So 192.168.56.102. And now I need to type my Mininet password, which is Mininet. So, okay, so now I can move the file. And the command to do that is going to be put, and then my directory where the file is, which is the current directory. So I'll type dot slash. So I'll put, and then dot slash UDP underscore pinger client.py. And then the address in the Mininet virtual machine. So I'll copy this, paste it in, and then I'll write pinger in between UDP and client. So pinger underscore. Unable to open. So that's strange. Where am I? UDP. Oh, so I tried to, yeah, so the client is not in my directory, so I need to do the server. Connect to Mininet again, and then I'll change this to server. Okay, it looks like that got transferred to my Mininet VM, so let me go check. I'll type ls. Oop. I'll type ls to list the current directory, and it looks like I have my server there. So I've already made a client file. So I will nano into that. Nano UDP Pinger client.py. And yeah, so this is the working code, and let me just delete all this. Okay, I've deleted my working code and now I can start fresh. Let's go take a look at the server file and see what's going on. So let me save this empty file. And now instead of Nano opening the client in Nano, I'll do the server. So it looks like we're importing the random library, and we're also importing the socket library. So we're creating a UDP socket object here. Um, and we're binding it to port 12,000. Ping number is equal to 0 while true. So an infinite loop, we're increasing the ping number by 1. We're creating a random value between 1 and 10 using the random library. We're receiving a message from the client on the socket. So we're receiving on port, let's see, 12,000. If okay, so if our random number is less than 4 and our ping num modulus 10 is not equal to 1, why would that be? And ping num modulus 10 is not equal to 1. Okay, let me read the comment. If rand is less than 4 is less, wait. If rand is less is than 4? Okay. Um, and this is and this not the first ping of a group of 10. Oh, okay. So the modulus is just making sure that it's not the first ping of the group. Okay. So yeah, so we're generating a random number between 1 and 10, right? And we're checking if that's less than equal to 4 or less than 4. And if it is, then we won't send the response back to the client. So we're simulating a packet loss with this. When we run the continue line, it will skip the rest of this code and it will jump back up to the while loop and will increase our ping number by 1. So yeah, there's our server. It's just infinitely waiting for a message from the client, and when it will randomly between 1 and 3. So our random number when it's 3 or below, then it will not forward the response. So it's at a 30% right now, response rate. So the assignment, where does it say this? The in highlighted in red, that's the most important information. Um, so in this server code, 30% of the client's packets simulated are lost. You should study this code carefully as it will help you write your client program. You'll need to modify the server program to simulate 40% of the client's packets being lost. So in our code here, if random is less than 4, so if it's 1, 2, or 3 out of 10, then it will be a packet loss. So if I just put this less than 4 to less than or equal 4, then that should be 40%. So that would include 4 as well. So 1 through 4, that will be a packet loss. So that's now 40, should be 40%. So my server, I think, is done. So I'll go ahead and save that by pressing Control X and then Y and then enter. Okay, so now let me open up my empty client file and we'll start writing it. Okay, so the first thing that I need to do is import the socket library. So import socket, and I need to get my host IP address and my port. So that would be the IP address of H1. And just to show you how we can get that again, you can type sudo mn to start the mininet. And then we can check the server IP address by typing h1 if config. So the INET address of host one. So that's 10.0.0.1. So I'll type exit and then I'll open up my client. So my host, you can do all caps, host is equal to the string 10.0.0.1 for my host one. And then my port, I think it was 12,000. So all capitals is going to be 12,000. And that's going to be a number, not a string. So I have my port and my host number. So now I need to create a socket object using the socket library, and I'm going to do that inside of a context manager. So the context manager keyword is going to be with, and then I'll create a socket object by writing socket.socket. And then the first parameter is going to be AF socket dot capital AF underscore INET. And then the second parameter is going to be socket dot sock underscore dgram or datagram for UDP. And then I'm going to make that as an alias S. So I'm declaring my object and I'm going to say as S. So that S is now my socket object. I'm going to go into my data or my context manager and I'm going to do 4 spaces for the indentation. And now I can let's see. I can create a while loop to send pings to the server. Well, let me define a ping count because the assignment wants us to send 10 pings from the client to the server. So I'll declare a variable called ping count is equal to 10. And then I'll create an index variable. So I'll write I is equal to 0. And now I'll write while I is less than, oh, ping count. So my I is going to be the index that I'm going to use to iterate with. And while it's less than 10 or my ping count, then I'm going to send another ping to the server. So, so that's 4. 1, 2, 3, 4. And so I'm going to get my alias, my S, and I'm going to do dot send to, which will send a message to my server. And then the string that I want to send, I can just define it here. So I'll just say ping, and then I'll need to encode it. So I'll do dot encode, and then the parameter of UTF-8, which will be the type of encoding. And now I need to pass in my host and port. So those are going to be as a tuple. So host, comma, port. So I'm sending this message ping encoded in UTF-8 to 10.0.0.1 on port 12,000. And now I'll wait for a response. So response um, is equal to s dot receive from, and then 1024 bytes is my maximum size. Okay, so I'm sending a message to the server. Let me increase I plus equals 1. So I'm sending a message to the server. I'm receiving the message, and then I'm incrementing by 1. So I should send 10 pings to the server. So I can print. Let's do ping space, and then I'll put plus, and then I'll put I, but I need to cast that as a string. So I'll write str and then parentheses. Let me move my mouse. So I'm casting that as a string, and then I'll put plus, and then a colon, and yeah, that's just setting up my print for the rest of the lab. So I'll save that. I'll run my Mininet to test it. And then I need to run the server on H1 in the background, and then I need to run the client on H2 in the foreground. So I'll write H1 Python 3 and then UDP Pinger server.py. And then to run it in the background. And then H2 Python 3 client.py. Okay, it looks like I have an error here. Socket, oh, so sent to, it's actually send, so my bad. Exit, nano UDP client. Where is it? Sent. Send. Save that, and then run it again. Okay, it looks like it pinged twice, and then something happened. So it could be that my server shut down. I'm not really sure. Let me that's strange. What's up with this? Address is already in use. That's strange. Hmm. Well, we can pretend that this never happened, right? Okay, so it's pinging twice. I don't know. I'll continue. Okay, so stop that. Open up my client. What could be going on? So printing one, printing two. I'll send two, waiting for a response. Oh, so I need to let's see. I need to, so what's happening here is the server it's having a moment where it's generating a random number, and that number is between 1 and 4, so it's not sending a response to the client. And that means that the client is just eternally waiting for a response from the server. So we can fix that by setting a timeout on the socket object. So I can create a new line below the I equals 0, and I'll write s dot set timeout, and I'll put a parameter of 1. So if it tries for 1 second and it doesn't receive a response, it'll time out. So now it will yeah, let's see. Oof. Okay. I forgot to put the and. Control C and then H2. Okay, yeah. So I'm getting an error here that it timed out. So let me add a try catch. So I'll exit and then open my client. And inside of the while loop, I'm going to write a try. So I need to do all the indentation manually. So 1, 2, 3, 4. Okay, so I'm trying that, and if I get a timeout, then instead of throwing an error, then I'll get an exception. So I think that's the right amount of spaces. Except, and then let me print ping, and then stri, and now I'll put let's see. So I'm not what did the homework want me to put? Yeah, so request timed out. So request timed out. Okay, so I'll save this now. Oh, let me open it back up and let me increase I in case I don't get a response from the server. So I'll go here and then I plus equals 1. And then I'll save that. I'll start my Mininet, run my server, and now I run my client. Where'd my .py go? .py. Okay, so it's printing when it times out. So that's good. Um, now, so in my expected output, I have RTT equals uh 0.105 milliseconds. So I need to record the amount of time that it takes to get a response from my server. So in pings 1, 2, 3, and 4, I'm getting a response from the server and it's not printing anything. Uh, so in those cases, I need to record the round trip time and print that. So let me exit and open my client again. So let's see here. So I'm sending it in this line. I'm sending the message to the server. So let me create a new line before there. And let me import the time library. So import time. And with this, I can record the current time and I can use that to get my round trip time. So I'll write start time is equal to time dot time. Okay, so I'm capturing my start time, and after I receive my response, I need to catch my end time. So here I'll get end time. Oh, time is equal to time dot time. And so I have my start. Oh, I put plus. So I have my start time, I have my end time. I can calculate my RTTT or my round trip time by subtracting the start time from the end time. So I'll create a variable RTT is equal to end time minus start time. And then I'm going to multiply that result by 1,000 to get milliseconds. Okay, so I think that's my RTT. And let me print, so the expected output should be RTT is equal to, and then the number. So let me write in this string, RTT is equal to, and then plus, and I'll print my RTT, which I need to cast as a string. Okay, so I should be printing my round trip time. Let's find out. So save that, start my Mininet. Run my server, run my client. Okay, cool. And that looks like it works. Um, ping 9 RTT. Why is it printing ping 9 twice? Hmm. Exit. I plus equals 1. Why is it printing it twice, guys? I don't know. Uh, hmm. Well, why would it be printing it twice? Ping 1, try, accept. I'm not sure. I'm just gonna move on. Okay, so I'm calculating the RTT, and if I look back at my expected output, so I'm getting request timed out, and after my after I've reached my ping count, or after I've sent all my pings, I need to print the summary values. And that includes minimum round trip time, maximum, and average, and also the percentage of packet loss. So let's work on min RTT first. So I'm going to go up to where my I is. and I'm going to declare a variable called min RTT. So I'm trying to find the minimum. So I'm just going to set it to 1000. So the minimum will be likely much smaller than that, or the all of my pings will be likely smaller than that. So the first ping I get will overwrite this. So after I calculate my RTT, I need to let's see here. Okay, so after I calculate my RTT, I need to check if it's less than my minimum RTT value. So if RTT is less than min RTT, then I'm going to set my new minimum RTT to the RTT that we just calculated, the round trip time. So 1, 2, 3, 4. So min RTT is equal to our current RTT. So that should be calculating the minimum. And then after my, let's see here. So after my while loop, I'll need to print that. So before the so I'm at my accept level, 1, 2, 3, 4. So that should be at the while level. It's kind of hard to tell in Nano, but so I'll print um what is it? Summary values. And I'll print a new line. So print and now I need to print my minimum RTT. So min RTT is equal to plus and then min RTT. So we'll see if that works. Start my Mininet. Server, client. Let's see. Can I? Oh, I need to cast it to a string. My bad. Exit. Nano. Min RTT is going to be str cast as a string. Okay, so it says that my minimum RTT was 0.2, and it does indeed look like that's the smallest one. So cool, that seems to work. I'll exit and then go back to my client. So I have my minimum RTT. Now let's set the maximum. So max RTT is equal to, and I'll set this one to 0 because everything will be greater than that. And after I check for my minimum RTT, let's check for the maximum. So I'm going to write if my RTT is greater than max RTT, 1, 2, 3, 4, then max RTT is equal to RTT. So I'm setting my maximum RTT to the current one if it's greater than the maximum. So now I need to print that. Print max RTT is equal to, and then I'll cast it as a string, max RTT. I'll save that and test it. Okay, so it says that it's 7, and I don't know why the first one is always like super big. I hope there's nothing wrong with my code, but I don't know. Nano UDP client. Okay, so I'm calculating my minimum. I'm calculating my maximum. Uh, I also need to do my average. So how could I do that? I need to add up all my round trip times and then divide them by the number of successful pings. So I'll need to also count the number of unsuccessful pings where the request times out because those shouldn't be included in the round trip time, right? So let me declare a new variable. Timeout count is equal to 0. and I'll count the number of times that it times out. So timeout count is plus equal to 1. And in order to, let's see. So in order to calculate my average RTT, I'm going to need to add up all of the RTTs where they're successful. So let me do AVG RTT average is equal to 0. And once I calculate my RTT here, I'm going to add it to my average. So average RTT plus equals RTT. Okay, down here, and I also have my timeout count. So calculating my average RTT is going to be average RTT is equal to average RTT, let's see, divided by, sorry, I'm forgetting how to do math. So it's going to be divided by the total number. So I'm going to get my, what did I name that variable? Um, did I name that? Ping count. So ping count minus my timeout count because I don't want to include those. So my ping count minus my timeout count, and then the division of my total RTT by that number is equal to my average RTT. So let me go ahead and print that. AVG RTT is equal to plus cast as a string, and I'll call it what is it? AVG RTT. Go test that. H1, H2. Okay, so it looks like my average RTT is 101.03. And I mean that looks about right, I guess. Yeah, I don't understand why this first one is so high. That's something to look into. So exit. So it seems that my average is working, and I also need a percentage of my packet loss. So let me go down, and how do I calculate that? So print, and that's gonna be my what is it? It's gonna be my timeout count divided by my total, right? Um, so oh, it's gonna be my number of successful pings divided by my total pings. So if like 7 out of my 10 pings were successful, then it would be 7 divided by 10. So I'll put uh let's see. So it'd be ping count minus timeout count, and then that would be divided by my ping count, and that should give a decimal, right? So let me save that. Oh, I did it again. str parentheses. There we go. Save. Oh, sudo h1 h2. Okay, so I had 3 timeouts. Why am I still printing that twice? Something isn't right there. But what is it? Try catch. Why? Why is that not working correctly, guys? I need your help here. So print ping. I'm not sure why that's doing that. Mm, I'll I'll try and figure it out and I'll let you know. But that's strange. Okay, so let me convert this to a percentage. So I'll multiply this by 1000. Am I still in my string? No. So I'll put an extra set of parentheses here and I'll multiply this by 1000. And then I'm in my print statement here, so and then a percentage symbol. So sudo mn and then h1, h2. Why is it doing that? I am increasing my I, right? Like I don't understand. Packet loss is 500%. So yeah, it seems I'm having some issues, guys. Oh, I multiplied by 1000, not 100. So let me change that. Oh, it's the RTT that I was supposed to multiply by 1000 for milliseconds. So that's going to be times 100 for percentage. Sudo mn, h1, h2, ping one. Oh, hold on. No. Yeah, I just can't figure out why it's pinging multiple times. I don't know what I'm doing wrong. Um, right, ping. Oh, oh, okay. So, so I'm printing here before I'm increasing I by one. Okay. I'm gonna sound like an idiot on this recording, but oh well. How many people are watching right now? One plus equals one. So hopefully that will fix it, right? H2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Yeah, it seems that worked. My maximum RTT is 24. That seems a little strange, but I got the basic formatting going. So if this isn't right, I'm gonna ask the professor and see if this number is right because that seems a little bit off to me. But maybe it's fine. I don't know. But it seems that I got a pretty good start going, so go ahead and implement that and let me know if you have any questions. What you'll hand in. So screenshots, so running the code and getting the results. So take a screenshot of this and then add it to a PDF document. So you can create a new Google Doc and then add the screenshot to that and save it as a PDF or a file download as PDF. Completed spreadsheet. So you're going to want to fill in a spreadsheet. So download the following. I actually didn't do this, so let's figure this out. Okay, so you're going to download this and then fill in the values. So yeah, minimum RTT, max RTT, average, loss percentage. Yeah, so go ahead and fill that in. Um, and then submit that as a PDF file as well. So the screenshot and then the spreadsheet. UDP Pinger server, UDP Pinger client, the PDF, the screenshot, and then the spreadsheet. So the rubric, you're going to want to comment. Let's see, where is it? Well-documented program. So you're going to want to write comments in your UDP Pinger, unlike I did. Good variable names are the best comments. But yeah, you're going to want to go ahead and write in comments, document your program, and make sure that you understand it, or you'll be able to understand it later, or somebody else will be able to understand it when they read it. And yeah, let me know if you have any questions. I'm going to ask the professor if those are acceptable numbers or if there's something wrong with that. So I'll let you know.